Okay, for this problem I will show how to get this table. Okay, in this case you have a population of 4, 5, and 9. And again, the same as the previous exercises, we have a samples of size 2, randomly selected from a population with replacement. Okay. The question is, does the mean of the sample proportions equal the proportion of even numbers in the population? So this is the population, 4, 5, and 9. The proportion of even numbers, well, the proportion means how many even numbers in this do you have in this population? How many even numbers do you have? You have 1. The 4 is even, 5 and 9 are odds. So this is the only even. So we only have 1 out of 3. So that is the population of, the proportion of even numbers. 1 out of 3. Okay? And we need to find the proportion of each one of the groups. Okay? So each one of these samples. So we set up a table just the same way we have done it so far in each problem. Okay, and I'll use this symbol, the p hat, for a sample proportions. Okay, so we have this number 4, 5, and 9, 4, 5, and 9, and this is pretty simple. For this group 4, 4, what is the proportion of even numbers? Okay, so we have 4, 4, so the proportion is 1 because you have 2 out of 2. I mean, 2 numbers are even numbers out of 2, right? So that is 1. Okay. On the next group, 4, 5. This is even, this is odd. So this is 1 out of 2. 1 half, or the same as 0.5. For this group, 4, 9. Only 1 is even number. You have 1 out of 2. So that'll be 1 half again. Let's see, for instance, for the group for 5, 4. Let's see, 5, 4. Get here. Only 1 out of 2 is even. So 1 out of 2 is even. For this group 5, 5, you have 0 out of 2. Okay, 0 out of 2 is 0. Okay, for this group 5, 9, again, well, 5, 9, we have no even numbers, so the proportion of even numbers will be 0. Okay, and again, 9 and 4, well, this is even. You have 1 out of 2. 1 out of 2. 9 and 5 is also 0. You have no even numbers here. 9, 9 is 0. Okay. Remember again, the p hat stands for sample proportions, right? Sample proportions. Okay. So we have to count how many zeros we have here in this table. We have 1, 2, 3, 4 zeros out of 9. How many 0.5 do we have here in this table? We have 1, 2, 3, 4. 0.5, which is the same as 1 half, and we have only one in this table. That's why we have 1 out of 9. Okay, so that's how you set up this table. Okay, and then again, if you want to find the mean of sample proportions. Okay, I mean, if you want to find this, the mean of the sample proportions, you need to find it out. Well, you can find it out with the calculator. Simple. Let's go to Stat. Let's go to Edit. Let me clear these two columns. I'll show you how to clear that. You move to the top, highlight this L1 and press clear. Do not press delete. Press clear. Clear. That's the one you want to press. And go to the right up, press clear, and then type 0.5 1. I'm sorry, it's 1, and then the corresponding probability 4/9, and 4/9 again, and 1/9. And then as we did it in the previous exercises, we go to Stat, calculate number 1, and then here you make sure you have L1 and L2. You have in blank here, you press second 2 to type L2, and then press calculate, and this is the mean of sample proportion. Let me capture that screen from that calculator. I'll capture the screen. Okay, indicate that this part is the mean of sample proportion. Mean of sample proportions. Okay, that is for again for even numbers. Okay, the mean of sample proportions, that is 0.3333, which is equivalent to 1/3. Okay, and this is actually the proportion of even numbers in the population, right? So this is a good estimator of the proportion of even numbers in the population. Okay, so the answer for this question is this part, sorry. Does the mean of the sample proportion equals to the proportion of even numbers in the population? The answer is yes. Okay, and do the sample proportions target the value of the population proportion? And the answer is yes again. Okay, does the sample proportion make a good estimator of the population proportion? Yes. Okay, we obtain it here and here, right? So that's how you do this problem.